Hello friends, welcome back to my YouTube channel. This is Assistant Professor Ramdas Pandit Bharsat. In this video lecture, we are going to study about thermochemistry. Now, in this case, you will take ice, solid in state, and if you will give the heat to that solid, it will absorb heat, and after that, that solid will convert into a liquid, that will be the water. Again you will give heat to that water, it will absorb heat and it will convert into gas in vapor state. Okay, and if you will give the cold condition to that gas, what will happen? It will convert into again liquid state, and after that again you will give cold condition, again it will convert into the solids and it will be ice. So like this we have seen temperature is going to be decrease and increases in this cycle, and we have seen the physical transformation of water. That means you can say the study of thermal changes which may cause chemical and physical transformation is known as thermochemistry. Now we have to see the objectives of thermochemistry, and in this case again you will consider one of the object, okay, which having some heat. So what will happen, that A objects will share the heat to the B objects, okay, up to equilibrium heat of both objects, and like this they will both share the heat to each other. That means in this case you can say both bodies are absorbing the heat energy or emitting the heat energy. And that's why you can say the objectives of thermodynamics, that is to determination of the quantities of energy emitted or absorbed as a heat in a various processes. And next is you can say to know about heat is evolved or absorbed between system and its surrounding. Now we have to see the next topic, that is specific heat of the substance. And in this case you can say every substance having different capacity to store the heat energy, and that's why it's required some temperature to increase the heat. So you can say heat required to raise the temperature of 1 gram of a substance by 1 degree. Okay, like this you can see next topic, that is molar heat capacity or C bar. And in this case you can say the amount of heat necessary to raise the temperature of 1 mole of a substance by 1 degree, right? And it is depends upon the nature of the substances. In this case you can take different examples like soil and metal. Okay, so metals having large capacity to store the heat or temperature, and soil having less capacity to store heat or temperature. So, and it is an intensive quantity. Okay, intensive quantity means it is independent to another. Okay, next topic we have to see, that is bond enthalpy or bond energy. In this case, the amount of energy required to break bond between two same or differ atoms, or you can say the amount of energy released when bonds are formed between two same or differ atoms. In this case you can simply say, if you want to make polyatomic atoms or monoatomic atoms or compounds, you can say, so for that formation of polyatomic compounds you will require some amount of energy. okay, or if you want to break that compounds, so you need some amount of energy to break that bonds. And in this case you should know, if you want to make or break the diatomic molecules like H2, HCl, so that times the same energy is required. So this kind of molecules, it will be H2 or HCl. And if you want to make or break the polyatomic molecules like CH4, okay, methane or ethane, like this, so that times you need differ energy, like these molecules you want to be break or form their bonds. So like these different molecules having different kinds of bonds, so different kinds of bonds having the different energies. Okay, now you can see here the tables, bond energy table is given. You can see HH bonds having 436 bond energy, HF bond having 565 bond energy, and you can see here HCl 431 bond energy is given, and HBr having 364 bond energy is given. So like this, in this way you can see all bond energies. Okay, CH having bond energy 414, and OH bond energy you can see here 463, like this. You can see C double bond C 619 bond energy is given, and C triple bond C 812 bond energy is given. Like this you can see here C triple bond C and 879 bond energy is given. So like this you can see all bond energies. So with the help of these all data we can calculate bond energy of molecules, bonds. Okay, now you will see here a formula for the bond energy given. Delta H reaction is equals to summation of bond energies of reactant minus summation of bond energies of product. Next is we have to see problems based on bond energy. That is, you can see calculate the enthalpy change for the reactions. Reaction is given H2 in gas form plus Br2 in again gas form, use 2HBr in gas form, and given that the bond energies of HH bond, Br bond, and HBr bonds are bond energies given 435 bond energy of HH and 192 bond energies of Br bond, and 364 kilojoule per moles bond energies of HBr bond. So respectively we have seen all these bond energies of given all these bonds. So we have to solve these problems, we have to see the solution. So all these given data we have to write in this way first of all, and then we have to solve next step by using the formula that is given here. You can see delta H reactions is equals to summation of bond energies of reactant minus summation of bond energies of product. So with the help of this reaction you can write in this way. Okay, bond energies of reactant, that will be H2 plus Br2. Okay, that means you can write in this way bond energy HH bond plus bond energy Br bond and minus summation of bond energy of product, that will be a 2HBr, that means 2 into bond energy of HBr, and simply we have to put these values in this formula. That is HH bonds bond energy, you can see 435 is taken, and 192 for BR bond, minus in bracket 2 into 364. Okay, so in this way you can write and calculate it. You will get 6 to 7 minus 7 to 8. And finally you can see here, in this way you can see with the help of bond energies we can see the change in enthalpy of reactions, that is minus 101 kilojoule. Now we have to see the second example. You can see here from the thermochemical equation is given C6H6 in liquid state plus 7 half O2, it gives thrice H2O in liquid state plus 6 molecule of carbon dioxide in gas state. Okay, and change in enthalpy is given minus 3264.64 kilojoule per mole. So calculate the energy evolved when 39 gram of C6H6 are burned in an open container. Now you can see here C6H6 means your benzenes. Okay, now 1 mole of benzene is equals to 78 gram. If you know the molecular weight of benzene, so that is 78 gram. And when the 78 grams of C6H6 burn, it evolved, and that is 3264.64 kilojoule. So when 39 gram of C6H6 burn, it evolve. If 78 grams, you will see 3264.64 kilojoule energy is there. So 39 gram of C6H6, how much energy will be there? So we have to do the cross multiplication here. In this way you can write, here 39 into 3264.64 divided by 78. You can simply see here we have to do the cross multiplication. Okay, in this way you can write and calculate that much amount of evolved energy, 1632.32 kilojoule. And now we have to see the next topic, that is resonance energy. And in this case you can see the increases of stabilization of a substance per mole as a consequence of resonance is called resonance energy. Calculation of resonance energy from heat of hydrogenations. Like this you can calculate the resonance energy with the help of hydrogenation. Okay, the heat of hydrogenations of cyclohexene is given, that is minus 29 kilocalories per mole. Okay, cyclohexene. In this way, that heat of the hydrogenation is always in negative. And you have seen here for one double bond in benzene, or you can say in a cyclohexane, minus 29 kilocalories per mole energy is given. In this way you can write for 3 double bonds. So you can calculate in this way, 3 into minus 29 kilocalories per mole. So you will see here minus 87 kilocalories per mole. That much value will be for 3 double bonds which are present in the cyclohexene, right? And this is a theoretical values, and we have to see the experimental value, that is you can see heat of hydrogenations of benzene. This is for benzenes, and that is minus 50 minus in bracket minus 87 is equals to 37 kilocalories per mole. And this is the resonance energy for the benzene molecule.